When you are combining rational expressions, either through adding or subtracting, and they have different denominators, you need to do the following. First, you need to factor the denominators of each rational expression. Next, you need to identify the LCD. You need to rewrite each rational expression as the equivalent expression with the LCD in its denominator. Then you can add or subtract, depending on what is asked of you, the numerators, and then write the results over the common denominator. And then finally simplify to lowest terms if possible. So first we have 11 over 6p plus 7 over 4p. So there's nothing to factor in the denominators, just 6p and 4p, so we can start looking for the LCD. So the LCD between 6 and 4 is going to be 12, and since everything has a p, our LCD is going to have a p. So this is what our LCD is, 12p. Now I'm going to show you the correct math way to do it, and then we'll do a kind of a shortcut way to do it for the rest. So what you're going to do is you're going to take your LCD and you're going to multiply it by both sides, top and bottom of each fraction. So when we do that, this denominator will cancel out, but it will also cancel out with this, leaving a 2. So I'm going to have 2 times 11, which is going to give me 22, and then the LCD of 12p. I'm going to do the same thing over here. 4p is going to cancel out with itself, and it's going to go into 12p 3 times. So plus 3 times 7, which is 21 over 12p. And then from here, we just add the numerators together. 22 plus 21, and get 43 over our common denominator. And that is the correct way to add two fractions or rational expressions together. Next, we have 5 over 3a squared b minus 7 over 6b squared. So again, gotta find the LCD. And there's nothing that we can factor, so we're just going to pick out what we need. So 3 and 6, we need a 6 for the LCD. A squared and no a, so a squared. And b squared, so we need a b squared. So here is our LCD. Now here's kind of a shortcut way to do this. We know that our LCD for each fraction is going to be 6a squared b squared. So we can just write that in right away. And then we can ask ourselves, what do I need to multiply the denominator, 3a squared b, by to get 6a squared b squared? And the answer to that is, I need to multiply it by 2b. And so if I multiply this by 2b and I get this, then I'll just do the same thing to the top, just multiply it by 2b as well. So I will get 10b. And then here, what do I need to multiply 6b squared by to get 6a squared b squared? I need to multiply it by a squared. And since I'm multiplying the bottom by a squared, I'm going to multiply the top by a squared as well. And I will get 7a squared. So this is kind of a shortcut way to do it, instead of having to go through the long way of canceling and then moving stuff around. So, same common denominator, so I can combine the numerators. 10b minus 7a squared over 6a squared b squared. And I can't simplify this, so this is the combined form of the rational expressions. Next, 2 over c minus 4 over 1 plus 1 over 5c plus minus 20. So I need to get my LCD, and unlike the others, this one I can factor out something. I can factor something out of this denominator. I can take a 5 out, leaving me with a c minus 4. So when I look at this, I can see that my LCD, both denominators have a c minus 4, but this one has a 5 and this one doesn't, so I need a 5 in here as well. So my LCD is 5c minus 4. So write my two fractions with the LCD. And what do I need to multiply c minus 4 to get 5 times c minus 4? I need to multiply it by 5. And I'm going to do the same for the top, which will give me 10. And what do I need to multiply 5c minus 4 here to get 5c minus 4? I don't have to multiply it by anything, but technically it would be multiplied by 1. So I'll multiply the top by 1 as well, and I will get 1. Now I can combine numerators, so 10 plus 1 is 11, and then keep the same common denominator, 5c minus 4, and this is the answer to this question. Finally, I have x over x squared plus 5x plus 4 minus 2x over x squared minus 2x minus 3. So I need to find an LCD. But first, I need to factor. So this quadratic can factor down to x plus 4 and x plus 1. So I don't need this anymore. And this quadratic reduces down to x minus 3 and x plus 1. So I don't need this anymore. So when I look at my denominators now, both of them have an x plus 1. So I could put an x plus 1 in there. But this has an x minus 3 and this doesn't, so I'll need one of those. And this has an x plus 4, but this doesn't, so it also needs one of those. So I'll put one of each for my LCD. So now I can write out my fraction with my common denominator, so x plus 1, x minus 3, x plus 4, minus x plus 1, x minus 3, and x plus 4. And now, what do I need to multiply this fraction by, or this denominator by, to get this LCD? The x minus 3. So I'll multiply the top as well by x minus 3. So I'm going to have x minus 3. And what do I need to multiply this denominator by to get the LCD? An x plus 4. So I'm going to multiply that by x plus 4, and I'll have 2x x plus 4. Now I can combine it into one fraction by subtraction. So I'm going to have x squared minus 3x minus, and it's going to be 2x squared plus 8x all over x plus 1, x minus 3, x plus 4. Now I can distribute the negative across the parentheses. So I'm going to get x squared minus 3x minus 2x squared minus 8x, all divided by x plus 1, x minus 3, and x plus 4. And now I can combine like terms up top. So x squared and negative 2x squared is going to give me negative x squared. Negative 3x and negative 8 is going to be negative 11x over my LCD. And there is nothing else I can factor or simplify. So this is my solution to this question.